Alright, in this video we are going to continue with what we were doing in our previous video, alright? So, what if the integral function, the numerator is a linear equation? So, we are going to look at integration of a linear equation on the numerator. And you are going to love it. Alright. So, all that we are saying is that what if you have P of S over Q of S, whereby where the P of S is a linear equation. You know that a linear equation is always in the form AS plus B. What if it's in such a form? Now don't forget that if it's in such form, it's not easy that you can split. No, it's not easy that you can split it that way. So the only thing that we can do is to one. Firstly, we are going to multiply A by the derivative. We are going to multiply A by the derivative of the function of Q of S. Then we add by B. Then we divide the whole thing by Q of S. Don't forget that A and B here, they are constants that we are going to find. They are all constants that we are going to find. And this is the same as so they are all constants that we are going to find, the A and the B. So the only thing that you have to do is that you are going to take the quadratic here. Now, it's always a linear over a quadratic, alright? Now, you take the quadratic equation, then you go and take the derivative of it. Then you multiply by A, so you just go and do the substitution into that. And let's just go on. To solve example for you to get what really we are projecting to you. So note here that the denominator is irreducible, but the numerator appears as a certain multiple of derivative of the denominator. So that is what we are talking about. So let's look at it. Okay, let me leave this one. So our first question, to find the integral of Alright, so you can see what we have now. Very good. Very good. It's going to be interesting. Now, this is a linear equation. That's what we are talking about. And this is a quadratic equation. So all that we are saying is that if only you have it in such form, quickly go and take the denominator. So you let B of S be equal to 5S plus 7. Don't forget that with the expression of this, you are not going to do anything with the numerator. Then you take the denominator, which is S squared plus 4S plus 8. Then you take the derivative of it, and that is going to give you 2S plus 4. So 2S plus 4 is the derivative. Very good. Then what's the next thing to do? The next thing to do is to go and do your substitution. So remember that, don't forget that the expression here is just algebra. This is the same as this. It's just algebra. So for you to integrate this as respect to x, it is the same as integrating this as respect to x. Then when you get to this, you can integrate it term by term. That is actually what we are talking about. So that when you are integrating it term by term here, you see that this will be a derivative and its function, or a function and its what? Derivative. When such happens, then it becomes interesting. And when you get to integrating this part, it will just be like the idea of completing the space. That is why we make length about completing the space before getting into this video. Because this is going to be a constant, this is going to be a quadratic. So it's not anything difficult. Very good. So let's move on. So we multiply a by the derivative of q, which is 2x plus 4 over or plus b, then all over the d of s. You see that? And this is the same as the integral of what? Or before that. So you can see that this is a function and its derivative. That is present there. And that is that. So to integrate this is the same as this and the same as this. So for us to integrate this, I hope you are watching. Very good. So from where we are, for us to integrate this, we need to go and look for A and B. Before you can take the integration, you have to go and look for the constant of A and B. And that is interesting because we are seeing something here whereby we need to go and apply our idea in partial fractions, in partial fraction, because what we are having here is in the form of a partial fraction. Now what? Let's take the calculus aside and bring out the algebra. P of x over P of x, and that is this over this. So this is 5x plus 7. All these over. This is identical. This is exactly identical to So this is exactly identical to this. Please, we are taking off the integration sign. So this is exactly identical to this. So therefore, we can equate the numerators. We can equate the numerators. Very good. So that we can now go and find our A and our B. Alright. So we go on to find that. Oh, seriously, I have made a question. Don't worry. So yeah, let us expand and simplify the right hand side. So we get 2as plus 4a plus b. Alright, so and the constant is 4a plus b. So to compare the coefficients, we have 2a to be equal to the coefficient of s, which is 5. Therefore, a is equal to 5 over 2. Then we equate this to this, but we know that a is 5 over 2. Very good. Therefore, b is just going to be -3. We get b to be -3. Wow! I just love it. It's just going to be interesting. Now, watch. We have a to be 5 over 2. We have b to be -3. Alright. You let 8 be there. Hope you have seen all the process that we have gone through. From the question, the linear on top, the quadratic is on the denominator, which is similar to this. So you just need to memorize this, and that is all. Or just know that you multiply a by the derivative of the denominator, then you add it to b, then all over the denominator. Then you express it to this. So the numerator don't come in the expression here, but it comes in when you are equating, because now you have that this is going to be identical to this. The left is identical to the right, and when you take the calculus off, that is the integration of. Then from your algebra, this is identical to this. Then you can solve this by partial fraction. So now that we have this, then we are now going to integrate. So I would like to clean the down one here. Yeah, when you get to this part, then you're almost done. Forget about this part and do this. Alright? Very good. So, after the substitution, now this one that we have here, we can bring out the constants. Okay? We can bring out the constants, and we are going to let it 2s plus 4. Don't forget, that is the derivative of this function. I'm splitting it. Bring this out. Or very good. So this is what we have. Now watch. I'm just going to code this right away, but before that, let me show you something. For you to see 8 with your naked eye. Now if you have integral of 2s over 4, and this is s squared plus 4s plus 8. Now note that this function is the derivative of this function. Alright. So if you set this to be u, s squared plus 4s plus 8 to be u, you get the u to be equal to 2s plus 4 ds. And the whole of this is the same as this. And that is the u. So this gets the same as du over u. And this is ln u. Simple. You can see that this is ln u. Exactly that. So this is just the same as 5 over 2 ln u. But the u is, hope you can see that. The u is s squared plus 4s plus 8. Then you close it. Minus here, you can choose to bring the 3 out. Then the integral of 1 over s squared plus 4s plus 8. Now, I know the reason why I'm not quoting this straight away, but I'll quote it straight away also. But before that, you can see that when you link this to what we have learned in our previous video, this is coming from the idea of completing the squares. So just leave this part because you are done with the integration there. Just go and quote it and integrate it by completing the squares. Alright, hope you know how to complete the squares already, so there is no problem there. Very good. So now, when you complete the squares of this, so you write x squared plus 4x plus 8. Then you go and complete the squares. Now here is 1, so no problem here. So 4 multiplied by half and square 8, and you are going to get 2 all squared. So x squared plus 4x, then plus 2 all squared minus 2 all squared plus 8. You know that already. Then you get s plus, because here is plus 2 all squared minus, and it's just going to give us 4. So that's going to be plus 4. Plus 4. So the completing of square of this quadratic equation is this. Very good. Then we're going to do the substitution back. And when you do the substitution back, please I'm cleaning it. So I don't have enough space and I don't want to clean them. So you see that this is the same as x plus 2 squared plus 4. And this 4 can be written as 2 squared. Then this is just, if I were you, I will not be doing anything seriously, just simple. Alright. This is just, we have plus here, so 1 over 2, that is A, the A is 2. Then that is tan inverse of U, which is x plus 2 over the A plus E, and you are done. So yeah, don't worry yourself, don't add any plus into it, then you come to this part. So that means that the results to this, is just going to be, don't forget, is 3 times 2 tan inverse then you add a plus C here. So that is the final answer for such question. Please, hope you can see that it's not difficult. It's just all about you knowing this. Now, let me add one more to you. And there are some times that it's not going to be a linear and a quadratic, but it will be in the form of trig functions. And I would like to include that in this video. I'll come back to it to show to you, and you will love it. Interestingly, what if is in trig form? What if is in trig form? What if I have it to be in this way? And what if I have it to be in this way? It doesn't matter whether sign is on top or cos is on top. It doesn't matter. And it doesn't matter where you are. It doesn't matter if you have cos plus sine or sine plus cos. It doesn't matter. And the coefficient of the A and the B there, they are all constants, and constant can be anything, alright? Just that, what if it's in the form whereby we have sine or cos on the numerator, on the denominator, whereby the denominator here, we have sine plus cos or cos plus sine. We don't care about what will happen in the numerator, we don't care about it. Whether we have sine plus cos or cos plus sine on the denominator, then we can still use this idea, alright? We can still use that idea. And let's see from the example. Let's see that from the example. And it's only this question that we are going to solve. So make sure you understand and you understand it well. In case you don't understand anything, just play back the video and you get it. Very good. So we have a nice question there. And in the same way, when we were solving our previous example, which was in terms of a linear on top and the quadratic on the denominator. So you can see that from the expression that we have here, the first thing to do is to identify that our P of S is 2 cos S plus 3 sin S. And our Q of S is cos S plus sin S. And we need to take the derivative of the first derivative of the denominator, because we need that in the expression. And when you differentiate cos, you get sin S, sorry, negative sin S. Don't forget these things. When you differentiate cos, you get negative sin S. But when you differentiate sin, you get cos S. Alright, then after this, you go and do the substitution. And you know that with the substitution, you are going to multiply it by the derivative of the Q of X and the function of the Q of X. And that is negative sin S plus cos S. You can choose to write it cos S minus sin S. Do the same thing. Oh, but sorry, I forgot to add something here. Here, if it's in the form of the trig, the only thing that will come here is that you are going to multiply this B by Q of S. That is it. That is it. You are going to multiply that B by Q of S. So you can see clearly that then this and this will what? Cancel. Alright. Let me write it well. When search happens, sorry for that, it's going to be in the form of this. Alright, so know the difference between when it's a linear and the quadratic, and when it's in the trig form. If it's in the trig form, the B will be multiplied by Q of X. So here you can see that this will cancel this and it will be left with only the B. Alright, so let's look at that. So here it will be B, then multiplied by Q of S. And we have Q of S to be cos S plus sin S. Or we don't need to bring it at all. You don't worry, let's bring it. And it's all this over Q of S, which is cos S plus sin S. Then this will be cos S plus sin S ds. Very good. So you can see that this is a function and it's what? Derivative. Alright. But before we go and take our integration, don't forget that it's 2 cos S plus 3 sin S. All this over cos S plus 3 sin S. Sorry, just sin S. So before we go and do the integration, we know that the integration just simple. This will cancel this, then take the integral of the B, then you go your way. This one is a function and its derivative. So it gets the constant multiplying ln of the denominator. And that is all, because the denominator is a function. It's not difficult. But there is one thing to do first. And that is why, even though we know that this will cancel this, but still you need to bring this over this. The reason is just that here you can see that this is going to be equivalent this is going to be equivalent to the right hand side. Take the integration of. You can see that this is going to be equivalent to this. And if it's equivalent, then we equate the numerators. And this is going to be equal to. So let's do it. Let's multiply the A through. Let's multiply the A through so that we can limit our work down. So here we get negative A. Very good. So here we just move on to go and compare the coefficients. And how we compare these coefficients is very simple. All that we do is that we group the cos and the sine. And we compare it to cos and the sine here. Just like that. It's not like the quadratic. It's not like the quadratic. So, we don't have enough space, but we can still manage. You can see that we can group this and this and this and this. Very good. So, looking at the right hand side, this one is already in that form. Let's look at the right hand side here. Or should I clean the top one? Please, I would like to clean this part. So, 2 sine 2 cos x, this is going to be equal to, so group the sine and the sine, the cos and the cos. So here we can get negative a sine s plus b sine s. I want to take my time with this. So we can factorize sine s out. We can factorize cos s out. So compare coefficients. The sine to sine, the cos to cos. So let's do that here. Let's do that here. Please don't forget the steps. From here, you go to this side. Now let's come to this side. So the coefficient of cos here is 2. But the coefficient for the right hand side here is a plus b. Very good. Put that in equation 1. The coefficient for the left hand side for sine is 3. The coefficient for the right hand side for sine is negative a plus b, equation 2. Very good. So you can see that when we do elimination method, we just add the equation 1 to the equation 2, and we are going to get a very nice thing. Add this to this, you get 5. Add this to this, 0. Add this to this, 2b. So we get b to be equal to 2 over 5. Oh, I love this. Then, simply, our a is going to give us negative, that is negative half, negative half. And you can confirm that on your own. Replace the b, which is 2 over 5, to whether equation 1 or equation 2, and find for a. You are going to get negative half. Alright. So now that you have this, then you come back. So we are done with the algebra. Let's clear up the algebra. Then we come back here. So wherever you see A, negative R. Wherever you see B, 2/5. Very good. Now that the A and the B is known, then the integration is just going to be easy. You know that this is a function and its derivative. So this is just leave cos x plus sin x. Please, here we don't write the function of the derivative, but we write the derivative is the function is here. So the function is the one on the denominator, which is cos x plus x, and that's what we have there. Plus, then here we have 2/5. Okay, so here you can see that this will cancel this. Very good. And when this cancels this, that means that we have to integrate because it's integrating term by itself. So when you integrate this, when this cancels this and you integrate this is a constant. So when you integrate, you get the term plus c. That is all. Easy. So that is it for that. Please, it's not difficult. When the person is giving to you, just know your formula that is going to be A multiplying Q of S, by which is the derivative over Q of S, plus the B multiplying the same Q of S over Q of S. How will you can see that? It's not difficult. Integrate both sides, and it's not difficult. And if we are talking of linear on the numerator and linear equation on the denominator, that one gets rid of this. That is why here will end you in completing the squares. So because we are going to have a constant here over a function. So that is that from these two concepts. And hope you have enjoyed it. I can't leave you like that unless I give you questions for you to also go and try your hands on it. Alright, so let me give you only two questions. You have to go and try on the integral of 2x plus 3 over x squared plus 3x plus 10 dx. Go and try on this. And the last one is that is sin x on the numerator, then the denominator we have cos x plus sin. Please, I have already assured you that it doesn't matter whether here is cos and sin, it doesn't matter. You get the denominator. And you can go by the process and you get your answer. But please don't forget that here you know that the numerator don't normally come in. It comes in when you are equating, that is when you are going for the A and the B, alright, and you are issuing the equivalent statement. That is when the numerator comes in. But when it comes in and you are comparing both sides, you can see that you group the like terms, the sine and the cos, then you compare to the left hand side. With the question that we just solved, you can see that here we have the cos and the sine on the numerator already. So we didn't face any challenge. But with this question, the challenge is that the coefficient for the cos is 0 cos s. Since it's 0 cos s, that is why it didn't come. That is why it didn't come. So when you are comparing and you get to the cos, the coefficient for the left hand side is just going to be 0 because it's not there. Thank you for your understanding. And let me add one more. Alright, so you can also try on this one. Until then, see you for the next video. What at all are we going to do for the next video? Let me see. Alright, so in our next video is going to be interesting. We are going to look at we are going to look at tangent of half angle substitution. Tangent of half angle substitution. And as far as techniques to integration is concerned, this concept is very important. In fact, gradually we are getting to the end of the techniques or the calculus 2. And as I said, it's all about the techniques. And gradually we are getting there. See you in the next video. And trust me, by the end of watching our video on calculus 2, there is no integration that you cannot solve it. There is none that you can't take the integration of it. Just trust me and follow it, and you're going to enjoy it the most. Thank you. See you in the next video.